Okay, in 11.4, we're going to do operations with radical expressions. So this is going to take us back to kind of the first few sections in this chapter. Okay, so like radicals is kind of like terms. So if you're going to add and subtract, you can only add and subtract like radicals. So if you have 2 square roots of 3 plus 4 square roots of 3. These square roots of 3 make them like. Okay, so it would just become 6 square roots of 3. It's kind of like adding fractions. The denominator stays. You don't add it. Okay, but it has to be the same. Okay, so the square root of a and the square root of a are both like. Okay, so you could add them together where you couldn't do it if it was the square root of 3 plus the square root of 4. Okay, unlike would be the square root of 4 plus the square root of 3, or the square root of 5 plus the square root of 2. Actually, this one up here would become 2 plus the square root of 3. Okay, but this one you couldn't do anything with. Okay, so they have to be like in order to add or subtract. Okay, let me get rid of all of these. There we go. Okay, so let's do some examples. So if we have, let's just do number 1. If we have the square root of 2 plus 3 square roots of 2, okay, there's really a 1 here because it's 1 times that, so this is going to become 4 square roots of 2. And that's it. You're done because the square root of 2 is not perfect. Okay. Number 2, negative 3, whoops, pretend like there's a 3 there. Negative 3 square roots of 5 minus 4 square roots of 5. Okay, well, negative 3 minus 4 is negative 7 square roots of 5. Okay. Square root of 10 minus 5 square roots of 10. So that's really 1 minus 5. So negative 4 square root of 10. You can't break 10 down, so you just leave it. Okay? Now, let's say you have 7 square roots of 3 minus the square root of 12. Well, those are not like, but you can make them like because you can break down 12. Okay, so remember, this takes us back to our first section. This is going to be the square root of 4 times the square root of 3. So 7 square roots of 3 minus 2 square roots of 3, because the square root of 4 became 2, square root of 3 stayed. Now we can subtract and get 5 square roots of 3. Okay, let me go over here and do another one. Let's do 3 square roots of 20 plus 2 square roots of 5. Okay, so I can break this 20 down. This becomes 3 times square root of 4 times the square root of 5 plus 2 square roots of 5. Okay, well, the square root of 4 becomes 2, and then the square root of 5 is going to stay. So this becomes 6 square roots of 5 plus 2 square roots of 5, which becomes 8 square roots of 5. Okay. All right. Now, so that's adding and subtracting. Now, if we go to multiplying, okay, so we're going to use the distributive property. Okay, so if we have the square root of 3 times the square root of 6 plus 7, okay, you have to distribute that square root of 3 to everything. Well, the square root of 3 times the square root of 6, you multiply that together to get the square root of 18, plus 7 times the square root of 3. You can't combine those to make 21. Okay, you can only multiply them if they're inside. Okay, well, 18 will break down into the square root of 9 times the square root of 2. So this really becomes 3 square roots of 2 plus 7 square roots of 3. And then you leave it just like that. I know it looks kind of funny, but you have to just leave it like that. Okay? Okay, now what if we what if we throw an x in there? Oops, this is the square root of 6x. So the square root of 2x times the square root of 6x times negative 11. Okay, so we take this and we multiply by both, the distributive property. So this becomes the square root, 6 times 2 is 12x squared, minus 11 times the square root of 2x, because you cannot put those together. You do not make that 22. Okay? Now 12 will break down to the square root of 4 times the square root of 3 times the square root of x squared. If you get really confused, just put the square root of 12 in your calculator, and it'll give you 2 square roots of 3. And then this x becomes x, so it's really 2x square roots of 3 minus 11 square root of 2x. So then you just leave it. If this under here was 2x, then you would subtract, but you can't. Okay, so you just leave it. Okay? I think I'm going to do one more of those, and then we'll move on to a different one. Okay? Oh, no, actually, that's just going to be it, because we have some more examples. I don't want to... Okay, so because we have other ones. Now, sometimes we have to use FOIL. Okay, so if we remember back to FOIL, so we have the square root of 5 minus 2 square roots of 15 times the square root of 5 plus the square root of 15. Okay, so when we FOIL, remember we do first, so square root of 5 times square root of 5 is the square root of 25. Outside, okay, well 15 times 5 is what? 75, 15, 30. Yeah, the square root of 75. Inside, this is going to become minus 2 square roots of 75. And then outside, minus 2 square roots of, I can't remember what 15 times 15 is, 225. Okay, and then we try to combine them. Okay, so the square root of 25 is just 5. Okay, now we can combine this because this is a 1, so negative square root of 75, or negative 1 square root of 75, because positive 1 and negative 2. And then minus, oh goodness, 2 times the square root of 225 is 15. So we have 5 minus the square root of 75 minus 30. Okay, well, we can combine the negative 30 and the 5. So we have negative square root of 75 minus 25. Okay, well, the square root of 75, now these are long problems. The square root of 75 is the square root of 25 times the square root of 3. Minus 25. Remember, this negative just stays. Okay. Oh, this is a 3. That's a 3. So negative 5 square roots of 3 minus 25. Okay, and then you're done because you can't combine anything else. Okay, I know that's a lot. Okay, but that's how you do it. First, outside, inside, last. Okay, what if, I'm trying to see if we want to do, what if it's given like this? Okay, since this is squared, remember, you have to take everything, oops, square root of 7. You have to rewrite it like this and then do FOIL still. Okay, so first, square root of 7 times the square root of 7 is square root of 49. Outside, so plus 4 square roots of 7. Inside, plus 4 square roots of 7. Outside, plus 16. Okay, well, this just becomes 7. This becomes 8 square roots of 7. This becomes 16. We can't do anything with 8 square roots of 7, so we just add the 7 and the 16 and get what? 23. 23 plus 8 square roots is 7 is what you would get there. And then you just stop on that one. Okay? Whoops. Okay, now, last few examples. Okay, the conjugate is when you write something's opposite, kind of. Okay, so I'll kind of explain it here in a minute. Okay, so if we have 6 over the square root of 5 minus the square root of 2. Okay, so remember we cannot have square roots in the bottom. Okay, so what we have to do is we have to multiply by the conjugate, which is negative 5 plus the square root of 2 over, not negative 5, the square root of 5 plus 2. Okay, plus the square root of 2. You see how it went from minus to plus, and that's because when we FOIL, we want those to cancel out. Okay, but remember we're multiplying this over this just equals 1, so it's not changing the value. So what we have to do is we have to multiply across. Okay, so this is going to become 6 times the square root of 5 plus the square root of 2. Alright, and then we have to FOIL. Well, the square root of 5 times the square root of 5 is the square root of 25. The outside becomes plus the square root of 10. Okay, the inside is minus the square root of 10, so those are going to cancel. And then negatives, so this is going to be minus the square root of 4, which is what we want, because we want all that to cancel so we don't have square roots. So on the top up here, we're going to have 6 square root of 5 plus square root of 2. We might not need to distribute that through, we'll see. So this is going to be 5. These are going to cancel because one's a positive, one's a negative. Minus 2, because the square root of 5 and the square root of 4. Okay, well this becomes 6 square root of 5 plus the square root of 2 over 3. Right, so that means these can cancel. So we're left with 2 times the square root of 5 plus the square root of 2. So then we can distribute and get 2 square roots of 5 plus 2 square roots of 2. You could have distributed the 6 through way up here. You would have just had to reduce at the end. It doesn't matter. It doesn't matter how you do it. Okay? Whoops. Let's do one more of those. Whoops. Okay. So if we have, let's say we have negative 4 over the square root of 10 plus the square root of 8. Okay, so remember we have to multiply by the conjugate, which is the opposite. If it says plus here, then you do minus, and they have to be the same on top and bottom. Okay, so this is going to become negative 4 times the square root of 10 minus the square root of 8. And when you FOIL this, it's going to be the square root of 100. And these middle things are going to cancel. It's going to cancel every time. Okay, it's going to become negative 8 square roots of 10, positive 8 square roots of 10. And then the last thing will be minus the square root of 64. It's going to cancel every time. That's why it's the conjugate. Okay, it's to make these middle things cancel out because we don't want them. Okay, so on the top we're going to have negative 4 square root of 10 minus the square root of 8. All over 10 minus 8. Okay, well 10 minus 8 is 2, so then we can reduce. So we're left with negative 2 times the square root of 10 minus the square root of 8, and then we distribute that negative 2. So it becomes negative 2 square roots of 10 minus 2 square roots of 8. Now, the tricky part about this one is this 8 can be reduced to 4 times 2. Okay, so you really need to break it down some more. because this can be the square root of 4 times the square root of 2. Well, this is going to be negative 2 times 2 times the square root of 2. Okay? So, and this is going to stay this. So what it will become is negative 2 square roots of 10 minus 4 square roots of 2, which I know is a lot. And I know these are lots of steps, so please write them down and look back at them. Okay?